So we've learned how to predict the charges on ions, and we know that ionic compounds are always going to have a positive ion and a negative ion because opposites attract. When we write the chemical formula for the compound, the sum of the positive charges have to equal the sum of the negative charges because compounds overall are neutral, they don't have a charge. So here are steps for writing formulas for ionic compounds. You need to start by writing the symbol for both ions, including the charges. The charges are what tell us how many of each ion we need, and so we have to have the correct charges in there. And then we need to make the magnitude of the charge on each ion become the subscript for the other. This is a technique generally known as crisscross, and I'll demonstrate this. This is not the only way to do it, but it's the way that most students prefer, so we'll go with that one first. Then you need to look at those subscripts and, if possible, reduce them to give a ratio of small whole numbers. You don't want H2, you don't want H4O2, you want H2O. And we'll do some examples. And then check your result to make sure that the charges are adding up to 0. So here's an example, writing a formula for the ionic compound that forms from aluminum and oxygen. We need the symbols for the ions with their charges. Aluminum is in group 3A, so we know it has a 3+ charge. Oxygen is in group 6A, and so we know the charge is 2-. The crisscross technique looks at these charges and says those are not the same. So I'm going to take this 3 and make it the subscript on the oxygen. I'm going to take the 2 and make it the subscript on the aluminum. That's what we call crisscross. But let's actually think about what we're doing there, because following rote instructions is nice and everything, but sometimes it'll screw us up. Let me find a color we can see on the black slide. The idea here is that we've got an aluminum ion with a 3+ charge and an oxygen ion with a 2- charge. And if we keep track of our total plus and minus charges, we've got +3 and -2. Do those add up to 0? They don't, right? +3 and -2 will give us +1. Overall, if we just had one of each of these ions, it would have a +1 charge, and that's not okay. So we need more of the negative charges to balance this. Well, we can't put in an oxygen with a 1- charge because they each come with a 2- charge. So the best we can do is put another oxygen in there. Now we have a total of what for negative charge? -4, right? -4 + 3, does that add up to 0? No. Now we've got too many minuses. We need another positive ion, right? So let's put in another positive ion, and that gives us a total positive charge of what? +6. And this is where you think, wow, we're just going around in circles. Now I've got too many positives. That doesn't add up to 0 either. Now I'm short on the negatives. So I'll put another oxygen in there. 3 oxygens, each -2 charge gives us a -6. And finally, these add up to 0. So +6, -6. There are 2 aluminum ions for every 3 oxide ions. We get the same result as we did by doing the crisscross thing, but most students think that the whole crisscross idea is much easier, right? The crisscross thing will work probably 95% of the time. Occasionally, though, you'll end up with the wrong answer. So it really is a good idea to understand what you're doing. If you're a math person, what we're looking for is least common multiple. The least common multiple of 2 and 3 is 6. And so we're going for +6 and -6. And if that didn't make sense to you, just crisscross. Let's look at another example. Magnesium and oxygen. Magnesium, we know from the periodic table, has a +2 charge because it's in group 2. Oxygen has a 2- charge. When we look at these charges, do we really need to crisscross them? Plus 2 and minus 2. The number is the same. The signs are opposite. These guys add up to 0. Just one of each, because the charges are the same. So I just think of pushing them together and being done. And you get MgO. The crisscross method will get you Mg2O2, and you need to look at that and say, hey, wait a minute. 2 to 2, I need the lowest ratio, which will be 1 to 1. So this is an example of how you can go astray using the crisscross method. Let's do an example. Write a formula for the compound that forms from calcium and bromine. What's the formula for the calcium ion? Ca 2+. Group 2, we know it's a +2 ion. What's the formula for the ion that forms from bromine? Br minus 1. I'm looking at the periodic table. Bromine is in the second column from the far right. I start at the far right, I go -1, backwards 1, it has a -1 charge. Very, very important to write the charges. Now we look at the charges. +2, -1, those are not the same. So you can do the crisscross thing. You can take this 2, and this is an unwritten 1, which becomes an unwritten 1 down there, and you get CaBr2. Thinking about it, I've got Ca2+ and Br -1. If I'm adding up, I've got +2 and -1 for my total charges. If I put another bromide ion in there, now I have -2, and that's what I'm going for. So I have 1 calcium and 2 bromide ions, and that's what this formula is telling us. Any questions? The math in this is not hard. It's the getting past all the funky symbols and the letters and just seeing what it is that we're doing. Okay? You can all figure this out, but some of you might have to get past this mental block. It looks weird. It looks crazy. You've maybe never seen anything like this before, but stick with it. We need to get this to be successful in the class. So we'll get a lot of practice with things like that in the worksheet that we do on Thursday.